Hello, my dear students. Today we are beginning with a new chapter of the section Study of Compounds, that is HNO3, that is nitric acid. It's a very important, very interesting chapter as well. We'll be studying the various properties, including the physical and chemical properties, the preparation, and some more facts about HNO3, that is nitric acid. Now, study of compound is full with the study of acids, the major acids, the strong ones like nitric acid, sulfuric acid, hydrochloric acid. There was one basic compound, that was ammonia. It is not a base, but yes, it shows the property of base. Yesterday we have done that topic, right? In a previous video we have done it. If you want to watch it, you can just go to the playlist of chemistry and you can watch that. So let's start with HNO3, nitric acid. So before beginning, let's just know some things about this. First of all, HNO3 is a very good oxidizing other to get oxidized. Okay, oxidizing is what? Oxidation is what? Addition of oxygen, removal of hydrogen, or removal of electrons, right? Now let's look at what type of bonding is done in this. So let's look at the type of bonding here. So in HNO3, we are having what? We are having one H, one N, and 3 oxygens, right? So let's see how they are bonded. So we are having one hydrogen here, right? Then, and one nitrogen, let's make, okay. This nitrogen is binded with 3 oxygen. Let's make the 3 oxygens. One oxygen, let's make the second one here, and the third one here. Okay, so these are the 3 oxygens. Then let's make the valence electrons. Nitrogen is having how many valence electrons? Who will tell me? Nitrogen is having how many valence electrons? 5, isn't it, guys? Yes.
Yes.
It's having 5, no? Yeah. So let's make 5 electrons in the outermost shell. 1, 2, 3, 4, and 1 is here. That is 5. Okay. Now what about oxygen? Oxygen is very, very poor. Oxygen also has some electrons, but very less. How many is it having? It's having 1. Let's just increase the width of this pen. Give me a minute, guys. Yeah. So oxygen is having 1, 2, 3, 4, 5, 6. Same here also. 1, 2, 3, 4, 5, 6. Okay. Same here as well. 1, 2, 3, 4, 5, and 6. And what about hydrogen? Hydrogen is having just 1 electron in its outermost shell, which is represented by a cross. Let's see how they are bonding with each other. Now see, the lone nitrogen, everybody knows that nitrogen is having 2 lone pairs, isn't it? One lone pair is on its head and one lone pair is at its toe. Yes. So both the lone pairs are binding with each other. Okay, binding with the oxygen electrons. So one has bonded here and other one here. Okay, this is 2. Oxygen actually has how many electrons in its outermost shell? It has 6. It wants to get 8. That means more plus 2, isn't it? It wants 2 more electrons. And nitrogen also wants 4 electrons. Yes or no? So now nitrogen has got its perfect pair. Okay. So now see what will happen. Oxygen here will get this one electron from nitrogen, and oxygen also wants 1 more. So how will it take? It will take from here. Okay. Now tell me, who all remembers the chapter chemical bonding? This type of bond is known as which type of bond in which the sharing of lone pair takes place? Tell me. What is the type of
Coordinate
bond?
bond.
Yes, this is called the coordinate bond. Okay, this is called the coordinate bond. So this is having 2 isomers also. I don't know, is it there in your syllabus or not? But okay, it's not there, so we'll not do that. If you want to just make it in a simple way, so you can just make it like this. There is one nitrogen, one pair has shared here. Okay, then 2 bonds here, one with one oxygen, and this oxygen is bonded with one hydrogen, right? Is it correct? Yes, it is. Okay, so this is the type of bonding which an HNO3 shows. Now, what happens in this? In this, H and O, H and O are having low electronegativity, and this group is having high electronegativity. Okay, this portion has a lot more electrons. That means it has a lot more negative element. That is why it will gain which charge? It will gain slight negative charge.
Negative charge.
Okay, and this positive side, which is having a low concentration of electrons, will gain a slight
Positive charge.
positive charge. Then, and hence we have got two poles. One is the positive pole and one is the negative pole. I hope that everybody is clear with these two things. Now, HNO3 is acidic in nature. How do we tell it? Because what is an acid? Acid is a compound which dissociates into water to give us what? To give us a H plus as the only positively charged. Can you see this H plus here? Yes, it is having a slight positive charge. So that is why HNO3 shows what? Acidic property. Clear, everybody? So that is the reason in an aqueous solution, the charges dissociates this portion, which is having H plus, okay, the positive side one. This portion has H plus ions. And as we know that the compound which provides H plus ions in an aqueous solution are called acids. So HNO3 is also called an acidic compound. Now we look at the various properties of HNO3, that is nitric acid. I hope that it's clear up till. So now guys, we move on to the physical properties of HNO3. First of all, we talk about the color. So it is colorless. But before that, anybody can tell me what is the color of NO2, that is nitrogen dioxide? It's
Reddish
Reddish
brown.
brown.
reddish brown.
Reddish brown.
Yes. So now see in HNO3, somewhere inside it we are having na NO3 के अंदर कहीं ना कहीं NO2 भी होगा ना. It must be there na, isn't it guys?
Yes.
It is there somewhere. So now tell me, इसमें भी थोड़ा सा कलर का हेर फेर बदल होगा ना, इसमें भी थोड़ा सा इसका कलर आ जाएगा जो रेडिश ब्राउन है. So what color will it gain? It will also gain some reddish brown color, but it will not be reddish brown. It will actually be yellowish brown. Okay, it is colorless when it is 98% pure. Okay, but in common, okay, in common it is
Yellowish.
68%, that is in 68% concentration, it is yellowish brown. What is it? It is yellowish brown. Okay, I hope that everybody has understood up to here. Now next we move on to the smell. Why is it yellowish brown? You all know the reason also now. Smell is what? Smell is suffocating.
Pungent.
Same thing what we call as pungent, suffocating, everything is the same. Pungent, suffocating, choking, everything you write now. Everything is the paryavachi of the other. Okay. Taste. What is the taste? Every acid
Salt.
is sour.
Sour.
Okay. Next, what is the density? Density is 1.54 gram per centimeter cube. That is density, you all know, mass upon volume, so gram per centimeter cube in 98% pure. Okay, and 1.42 grams per centimeter cube in the common one, which is there in the market, and which is there in the market is having what is the percent of concentration? I told you just now. It's
68%.
very good. Yes. Now we come to the toxicity. Tell me, is it an acid? It is acid. It should be toxic, no?
Yeah.
No, it is non-toxic. What is it? It is non-toxic, but corrosive. Very important. There's a difference of the there's a big difference, okay, between toxic and corrosive. Okay, corrosive means it damages the skin, corrodes the skin or the surface where it is. Okay, and toxic means it is very dangerous, very for your health and all. Now solubility, it is an acid, so obviously it will be what? It will be highly soluble, isn't it, dear students? Now we come to the boiling point and the melting point. So boiling point is what? It is 6 degrees Celsius and melting point is minus 42 degrees Celsius. Okay, these were all the physical properties. Okay, now we move on to the chemical ones, but before continuing, we all know that it is soluble. In the examinations they might ask you, how is it soluble? Perform an experiment. We all know the experiment of the fountain, isn't it? Everybody knows the fountain experiment. If you don't know, you can just watch my
Yes,
previous
sir.
videos. In that it is illustrated very nicely. Now let's move on to the chemical properties of this acid. Chemical property. Yes. So now we move on to the chemical properties of nitric acid. So in this, we'll be talking about the aqueous solution. What is the type of aqueous solution? It is highly acidic. When it is in aqueous solution, it is what? It is highly acidic. Combustibility, is it combustible? No, it is non-combustible. Okay. Next, thermal dissociation. HNO3 can be broken down into what? Into
H plus and NO3
NO2, H2O, and O2. This is the dissociation. Okay. Just now we don't know the temperature. Okay. And this is an aqueous state. Next, reaction with bases. Reaction with bases, it will give us what? It will give us
salt
salt
and water.
plus water. Because it is an acid, it will perform which reaction? Neutralize. Now let's see what are the types of reaction it does with various elements like metals, metal sulfides, carbonates, and all. So let's start with it now. So now let's see the reaction with metals. How does it react with metals? Let's take a metal for instance. Let's take Fe, that is iron of ferric, and HNO3. How will it react? Let's see. It will give us the nitrate and then water. Okay, so it will give us what? Fe will displace hydrogen because it's above it in the metal reactivity series. It will give us what? FeNO3 whole twice plus H2O. Okay,
Yeah.
and one more thing that we'll get is
NO2.
NO2. Yes, so this is the reaction. Now let's write a simplified reaction so that we know what we'll get every time. Okay, so it will give us what? When it will react to metal, it will give us the salt, it will give us water, and it will give us nitrogen dioxide, isn't it, guys? Yes. So nitrogen dioxide. That's why. Okay,
Sir,
that's
will
all.
it be
Okay.
liberated?
Yes, it will be.
So
That's
we have to give
understood.
the upward arrow. Yes, yes.
Yeah, that's understood. That's just so obvious. Next, Zn, let's take zinc plus HNO3. Now we know the general equation, so we will just write ZnNO3 whole choice plus H2O plus NO. Okay, and this will be liberated. This is NO. Okay, by the way. Next we move on to let's take concentrated HNO3 now. So let's take Zn again and let's take HNO3 that is concentrated. Just now it was diluted. Here also it was diluted. And now we'll take concentrated. Okay. So in concentrated one, it will give us what? It will give us, I will tell you. One thing will change. That is, it will give us
NO2.
NO2. Okay, that has changed. Okay, so that is all. So therefore we can just write a general equation here that HNO3 plus metal will give us
Salt.
metal nitride metal nitrite or nitrate.
Water.
I'm sorry, nitrate. Nitrate, water plus
Nitrogen dioxide.
NO or NO2. Okay, any one of those. Now, next we move on to the next equation, next reaction. Next we'll see how does it react with metal sulfides and bisulfides. Okay, so reaction with,
Sir, show that
after this,
HNO3 plus metal. I will write.
yeah. So after this, we'll just end the video here, and then you have to join again in the next video. We'll continue with this only. So metal sulfide and bisulfide. Okay, so let's now see what will it give. So I'll write the general equation first of all, and then I'll end the session. To know, you have to just watch the next session. Evolved is NO2 or NO. See, when there is HNO3 in dilution, that is dilute, then we'll get NO. Okay, and when HNO3 is there in concentrated, we'll get NO2. Okay, that is the difference. Now let's see the general equation of this, and then we'll end the session. You have to join again with the same link. Okay, so if we take anything like metallic sulfide, okay, let's take metallic sulfide plus HNO3, it will give us metallic nitrate plus water plus SO2 because sulfur dioxide is present in them. Okay, so to see this, you have to watch the next video of the series of study of compounds. Till then,